Hello and welcome to the course. In this course, you'll learn about YARA. It lets you search for patterns and text inside files, and you can use this to detect malware. So, of course, the first step in malware analysis is finding that you have malware at all. And YARA can really help you with that by finding suspicious patterns, for example, using a combination of Windows functions or just suspicious text in itself. Like, for example, maybe there is some text in the executable that asks for Bitcoin, for a payment in Bitcoin. So then you know, okay, that executable is probably suspicious because Windows programs shouldn't ask you to pay Bitcoin. So you can search within files, within any executable. And in this course, we'll really go into that. So different malicious files. With the strings commands, you can search inside an executable. For example, there's many gibberish strings here, but you'll see we can scroll up and you'll see all kind of things inside the executable. And then we can define Java rules to detect suspicious executables, to detect Windows malware. So we'll go into it step by step, first by covering Java rules, and then we'll actually do that on some real-world malware. Instead of just theoretical, it will have a real-world component where we analyze real-world malware to see can we detect them with our own Java rules. And it's a step-by-step process. So when you do this, make sure you don't do it on your regular computer that you use for all your work or all your study. Make sure you do it on another computer that you don't use for anything, or if you must, then you do it in a live VM that you will wipe after you restart it. But ideally, do it on a computer you don't use at all, that doesn't have any of your data, because you don't want to accidentally run some malware and then struggle with that. However, of course, this technology, it doesn't work just on malware. You can also analyze regular Windows applications that are not malicious, and then you don't have any risk either. So it depends on you, but I recommend doing everything on a separate computer, or if you must, inside a VM, live VM, where that malware won't actually affect your own computer. Piece of malware in a huge pile of files. That's exactly what you're up against when you're looking for malware. There's hundreds or millions of files on your computer or any machines you own. There's many files. And how do you find malware in there? Because there's so many of them. So that's where Java rules come in. So it's spelled like this, or lowercase. And these rules, they're like the detective's toolkits for spotting patterns in files, especially for malware. So with Java, it's one of the most important tools for detecting malware. And it's basically like your own search engine, where you search for specific patterns in files, like for a specific file size, for any keyword like virus, keylogger, or anything else that search for inside files automatically. And these patterns can really be anything. So when I say files, I really mean anything you want to analyze. It can be programs, documents, random logs, and anything else. So a lot of files are on the computer, so your workstation, but also on servers. If you're not familiar, a server is just a computer, usually one running websites or storing data. So malware often targets those systems, but also consumer electronics. So YARA can be a game changer in detecting malware. So the first thing you'll want to do is to install it. Now, the installation is different depending on your system, whether you're on Mac, Linux, or Windows. On Linux, you can simply run an update like this. That will update the system, and then you can install YARA with a single command like this. So this is for Debian-based Linux systems, Debian, Ubuntu, Kali Linux. You can install it like this. If you use another Linux system, you might have a different package manager, but the principle is the same. So that will install YARA onto your system. So I'll include the steps for installation for different operating systems. But for now, let's make sure YARA is working. So in your terminal, type YARA -H. That should output something like this, where it tells you YARA, the version number that it searches for patterns in files. And this is basically the help page. -A shows you the help page, the help page or the help menu, where it shows all of the options that are inside YARA. So there's a lot of things in there. So by now, you might probably be wondering, okay, but how do you actually use this YARA? So that's what I'm going to cover in the next video. I'll walk you through writing your first YARA rule, and by the end, you'll have an idea of how it works. So now you know what YARA is and why it's such a big deal in malware analysis. In the next video, we'll jump into writing your first rule. Don't worry, it's simpler than it sounds. All right, it's time to get hands-on. Writing your first Java rule might sound a bit intimidating, but it's actually really simple. By the end of this video, you'll not only have created your first rule, but you'll also know how to test it, troubleshoot it, and expand on it. Let's get started. So let's start with the basic structure of the Java rule. Every rule has three main parts: the name, so that's simply a name, the string, and the condition. So the name is what you call the rule, like the title of your rule. The strings are the ingredients, the exact patterns you're looking for, and the condition is the logic that says, if this happened, match that rule. So let's open a text editor and create our first rule. Depending on what text editor you're familiar with, use that one. For simplicity, I'll use Nano in this course. So we can open Nano with your first rule. And the extension of the file will be a .jar file. So .jar for a Java rule. So this will create a new file, first_rule.jar. I'm using Nano, but you can use anything you like. If you want, you can simply use Notepad kind of editor or Vim or whatever you're used to using. So now we're going to type a rule. Now, as you might imagine, it simply starts with the word rule, the title of your rule. So we're going to detect hello world. Then it has the begin and end symbols of programming languages. Those are these symbols, the curly brackets. Then the strings, what it has to look for. So we're going to look for the text hello world. Then the condition, and the condition is simply if the text exists. So this is the entire rule that simply looks for the word hello world inside any file, and that's why the condition is simply text. So you'll see this gets stored into text, and then if that text exists, then it should tell us. So then let's break it down quickly. The rule keywords is the start of every Java rule. Then we have the name, detect hello. Under the strings, this is what it has to look for. And then we have the condition that says if the rule matches, or the rule matches, if it finds the text, which is this one, in the file. So we're going to save it, press Ctrl O to save, hit enter, and then press Ctrl X to quit. We're back in the Linux terminal. So now we need to test this with an actual file. We can create some files to test. For example, we can create a file with hello world inside the file. So we could create a file in this way. Sure, the quote is there. So this is one way to create a file, or you could create a file with a notepad editor like this. So this is another file. Let's save it. It doesn't really matter how you create files, just as long as you create some files. And also let's create a file that's totally different. Let's call it file 3. So we created 3 different test files. And now we're going to actually check those files. So we're going to use the YARA rule and see on those files. So we type YARA with the name of our rule. Remember, first_rule. This is the file name for our rule. and then the file name we want to test. So file 1, hit enter, and you'll see that didn't match anything. We can do the same for file 2, and you'll see it detected in file 2. And let's also do for file 3, and it didn't detect anything for file 3. So let's figure out why that is. So we open the rule here, first rule.jar, has to be exactly as this string, hello, comma, world, and then the exclamation mark here. It has to match exactly. Now, if we open the files, if we do it manually, you'll see this one doesn't have the exclamation mark, so it doesn't match. And this one does. And the third one doesn't have it either. So it actually works, our rule. It finds those files that exactly match the required text, the required string. So you can run this with different files, but you'll see it's case sensitive. So when this exclamation mark, because of the exclamation mark, it didn't find this text in the first one. It has to be exactly as it is. It is case sensitive, but also has to match exactly. So that's an important thing with YARA rules. For example, if we would create another file, let's say another file that's exactly as it is, but now make it uppercase. And let's see if it finds that. So we run it, file 4, and you'll see it doesn't detect it. So YARA is case sensitive. Now there is a way around it. It's by typing no case at the end. So then it ignores the uppercase, lowercase, and so on. So let's run it again with the last file. And you see now it detects it. So now it detects lowercase and uppercase. It doesn't matter if, like in the second file, it is spelled like this, if it's spelled like this, or even if we create a new file with lowercase. So now we have those two files. And if we run it with YARA, you'll see it detects it in both files. It doesn't care whether it's uppercase or whether it's lowercase. In both cases, it will detect it. So now it matches. So this is super useful when you're dealing with patterns that might show up in different formats. One pattern was a good start, where we have a simple rule, detect hello, that searches for hello world in uppercase, lowercase, or any case. If that exists, if text exists in a file, it matches. So we could run it with YARA, first rule, and then a file name like file1.txt, and it then detects that or not, depending on the contents of the file. So for file 1, this is the contents. So it found that pattern hello world inside file 1 using the YARA rule. Now, let's face it, malware isn't usually that simple. It isn't just one text that should be found. Usually it's multiple. So we can create a new rule when it looks for multiple strings, like this string or that string, and it can be in different order. It doesn't really matter. So with YARA, that makes it easy. So I'm going to show you exactly how to write that rule. So first, let's create a new file. I call it second_rule.jar, and we can make that awesome rule. So we type rule, and then detect_multiple. That's simply the file name, detect_multiple. You can name it whatever you want. We look for texts. So we look either for text 1, could be hello world, or text 2. And while we're at it, let's make sure it's in any format. So lowercase, uppercase, we don't care about it. So we add no case to the end. Then we type the condition. So either text 1 or text 2 in the file, then it is malware. So we save it and make sure we have the ending. So you'll see here the begin symbol of the rule and the end symbol. So make sure to add them. Save it, and now we run it. So we type YARA second rule with some file, like file 1, and it detects the file. Now we can do this also for a file containing by. So let's create a new file. Gonna save it. Let's call it file10.txt. Let's see if our rule worked. So on file10.txt, and it detected that as well. So pretty cool, right? It can detect different patterns. It doesn't have to be only one type of text. It can be multiple kind of text that you're looking for in a file. So it can be that it's either or the file. So it can be either hello world or by that appears in the file, because we define or here. But this is not the only keyword we can use. It can also be and. So we could have a rule. Let's name it third rule. And this time I call it third rule, where instead of this or that one, it has to be and. So that works as well, where both have to appear in the file. So now if we try that rule, you'll see it won't have any matches. Because while the text appears in the files, it has to appear in both. So it has to have both hello world and by in the file. We could modify the file. Let's run it again. And now it matches, because in the rule we strictly defined both text1 and text2 have to appear in the file. It doesn't matter uppercase, lowercase, but it has to appear. And if it doesn't match. So it can be either or. There is no limit. It could be you have rules where you look for a single thing. It could be a rule where you look for multiple things, so two kinds of text using the or keyword, or it can be a combination where it has two texts and it looks for both of them in the file. So that's YARA in simple examples, simple rules. We have some real-world malware in the downloads folder. If I open the downloads folder, you'll see two files here, an executable and another one. Two malicious files. And so far we have been searching for text inside files. For example, we would search for patterns, but we can also use file size to detect files we might want to investigate. So how does that work? Well, we simply create a new rule, and the rule could be check size, where we define a condition. And the condition being that the file size is smaller than, for example, 10 megabytes. So it can be useful to to add that to your rules, the file size, for example, files that are very, very small or unusually large, or any specific size that might be suspicious. So I'm going to save this rule. You'll see I called it check size. So let's call it check size.jar. Then we run it. Let's see what those files were called. So very long names here of those malicious files. So we run it in YARA, check size, that's our rule, and then the file. You'll see this one matches, it's smaller than 10 megabytes. And you can do the same for the other one. You see it finds those malicious files that, because they are smaller than 10 megabytes, it classifies them as malicious. You see here the rule 10 megabytes. So it could be megabytes, it could be kilobytes, it can be gigabytes. It doesn't really matter. It can be smaller than, it can be greater than. You can add file size to your rules. What happens a lot of times is that malware either is very, very small or very, very large. So you could add that to the rule. If you're looking for specific malware that's always around the same file size. So it doesn't have to be just patterns you look for. It can be text as well. And maybe some files are unusually small, so they're so small they can't actually be a useful program. So that could also be very suspicious. So yeah, it's a cool trick that you can use when you can add file size to your YARA files. So besides looking for text patterns, you can use size as a feature to detect malware. Okay, we have a malicious file here, the executable malware for Windows. So what we can do, we can create our own YARA rule to detect this type of malware. So first, with YARA, we know that we can look for patterns for text. So let's first take a look, search for text inside this executable. So we go to the downloads folder. Then you'll see I have that malicious file here. And I can simply look at what kind of text is inside this file by typing strings and then the file name, which is a very long file name, but that's the malicious executable. So with strings, we can look inside the executable file, and it will output any kind of text that's inside that file. Make sure it's strings. You'll see it finds all of this text inside the malicious software, inside the malware. So many different things are in here. You see they are using SSL, which is often for encrypted connections. So that might be suspicious for a file. You'll see some other information here. See if we scroll up, you can look at all this information. You'll see they request privileges. So we might look for that specific words in an executable if they request privileges or require administrator, or we could simply search for SSL because maybe any application we install shouldn't use the internet, or at least it should tell us. So we can write a YARA rule. So we'll type rule, and this I think was believed Mirai malware. Let's call it detect malware. So let's save it. Save this rule. And we type strings. So the condition, we might be interested in if it has, if it asks requested privileges. Another text we are interested in is if it has require administrator in it. And we might add no case. We don't really care about lowercase or uppercase. Let's see, maybe we're interested in something else as well. If we scroll in this file, you see there's a lot of gibberish in here, but you can also find useful strings. So, for example, maybe if there is SSL in appearing, for example, we see SSL Corp. That's not necessarily malicious. That can be for legitimate purposes, but let's just add it for completeness. Because not every application needs to communicate with the internet. Okay, so the condition will be if either text1 or text2 or text3 is inside the file, that is suspicious. So I'm gonna save it, and we run YARA. So YARA detect malware with our file, and you'll see it detected the malware. Now, just for completeness, let's create another file. So in the downloads, let's create some new file. So test.exe, just to verify that this actually works. So we type YARA detect malware with test.exe. You see it doesn't detect it. Test.exe is an empty file, so it's not malicious. But when we try it on the other file, which is this long file name, you'll see it now detected. Now now it detects malicious software if any of these appears in the file. So that's where sometimes virus scanners, they detect malware that's not malicious because it might find some pattern that's legitimate. For example, maybe there's a program that really needs administrator access for legitimate purposes. However, this would detect malicious malware that, for example, any executable now that asks for privileges for administrator access, it would detect those kind of software. So it filters down or it gives you an indication whether an executable is potentially malicious. Most malware is not created from zero. Malware often use default Windows API, default Windows functions. So by searching for common strings that in Windows API or common strings in Windows library, we can find out or we can detect a lot of malware. So in this session, we'll focus on that. We'll focus on rule that identify malware that uses those Windows API. So on the downloads folder, I have lots of malware files. So if I go to downloads, you'll see many different malware files. All are malicious executable, recently created by people around the world. So we're going to try and detect those. And so how do we do that? Well, we'll create a YARA rule. So we'll type rule and I might give it some name like detect or Windows. I'm just going to call it Windows, but you can call it anything you want. And I'm going to save it. So windows.jar. So we're going to look for strings. For example, that you'll always see in an executable is about DOS mode. So let's, for simplicity, add that to test it. Okay, so we have a simple test rule. And let's see if we can run YARA on the entire folder. So we run windows.jar on the downloads folder. We might want to specify the full path. Enter. And you see all of them contain that text, but this is true for any program, any Windows program. So we're going to scan for different kind of text that often used by the Windows library. So many executables, they do different tasks. For example, run other programs, load other libraries, and so on. And that are default in Windows. So some of them are virtual alloc. So that is used for getting memory space. And malware often does that to inject their malicious code. They often load libraries, so they load different modules. And the reason is that once they load different modules, they can do more things. So it's a legitimate in many programs, but also in malware. They might be interested in memory addresses or the address of certain functions. And especially malware, they often try to create new processes. So they might want to start command line or PowerShell for executing malicious commands. So a Windows function for that is create proc or process A. That creates a new process. So we can try to see if this combination of Windows functions are in the executables. Let's clear the screen here on the right. So if the combination of these Windows functions are loaded, that could indicate malicious behavior because it means it wants to allocate memory, usually for injecting malicious code, wants to load different modules, it wants to create different processes, which is unusual because a lot of programs, when you start them, they don't start other processes. And yeah, let's try this. So these are some common Windows functions. Let's run our rules. And you'll see it detects the combination in those executables. So we can now say with a moderate level of confidence that these executables are malicious because they start new processes for one, and they do some other things that is a bit suspicious in itself. So you'll see it is a bit of a probabilistic method. So you try to find out the behavior of an executable using Windows standard Windows functions. And then the combination of them, it might give you a moderate confidence that that executable is malicious. So this is not true for any executable. If it has this pattern, we can say with a moderate confidence level that it's suspicious, because it allocates memory, it loads the DLLs into the memory, and also it starts new processes. So that is a very suspicious combination. Now you can of course search for different things. These are not the only Windows functions. There's lots of them, but you can sort of detect what kind of behavior an executable does without actually running it, just by defining which kind of Windows functions are used by the executable. So that can give you a lot of detection ability